Hey guys, welcome to part 3 of this course, our first C program. In this course, or in this tutorial, we are going to write and run our first C program. So let's go ahead and do that. If you are on Windows operating system, please just follow this. I'm going to leave the link of this website in the description of this video, so just browse and then look for how to create a file on code block if you don't yet know how to do that, and that will be okay for Windows. Now for Linux or Mac operating system, just create a file called first program.c in your operating with your favorite code editor. Then we are there. Here I have downloaded the Visual Studio Code where I'm going to edit my C code. So the extension for a C code is .c. So now we can follow. So you can type this into your code block. There's no problem, and then compile it. Here I'm just on my Linux operating system. So let's go ahead and analyze this code. Although this is a very simple program, a lot of hidden meaning is packed into the meaning symbols you see in the code. Though your compiler understands it, you can only guess at what the code, sprinkled with some familiar English words, might do. One of your first jobs as a new programmer will be to learn many words and symbols of the C programming language, the language your compiler understands. Once you learn the meaning underlying the code, you will be able to talk to the compiler and give it out your own orders and build any kind of program you are inventive and resourceful enough to create. But note that knowing the meanings of arcane symbols is not all there is to programming. You cannot master another language by reading a translation dictionary. To become fluent in another programming in language, you have to practice conversing in that language. Learning a programming language is no different. It's not different, please. You have to practice talking to the compiler with the source code you write. So be sure to type in the code example that we have here, and feel free to experiment and alter it with your curiosity as your guide. Okay, let's dive into what we have there. We have h include stdio.h. Before understanding what this line does, you have to know that your machine already comes with pre-installed with some C software code. The code is there to save your computer drudgery of writing code that performs basic common tasks. Reusable code is referred to as library. And so our first line in our example program signals to the compiler that we would like to check out some code from the library and make use of it in our program. Here, we are borrowing code that will help us print text to the screen. The way we tell the C compiler to include library code into our own code is by using what is called a preprocessor directive. One of the very first tasks your compiler will perform is to search through your source code for the preprocessor directives, which modify your source code in some way. In our case, we have the h include preprocessor directive tells the compiler to copy source code from library and insert it directly into the code where the processor directive is found. Since our directive is at the very top of the file, the library code will be inserted at the top of the source file. Note that this all happens in the computer's memory, so the original file on your disk never actually gets altered. But which library code should a compiler insert? The next bit in the line, the stdio.h tells the compiler to copy and paste the C code from the stdio.h file into your code. The angle bracket surrounding the file name tells the compiler to look for the file in the standard library as opposed to say your own personal library of reusable code, as we are going to see in the later tutorial. Note that files with the .dot extension are called header files. The stdio.h header file contains many functions related to input and output that are defined according to the C standard. Though this header file gives us access to many different functions, the only library function we are interested in from is stdio.h with a print function. Okay, but what exactly is a function? Let's take a look at the next line in our code so we can begin to get an idea. We have here the int main void. Here we create a function named main that is the starting point for all C programs. So all C programs require the function called main, or they will not compile otherwise. Our function name is surrounded by two mysterious symbols, int and void. The int bit tells the compiler what kind of value our function will return to the void bits while the void bit tells our compiler what kind of values will pass into our function. We will skip over what exactly this means for now, as this value will be covered in more detail in the later tutorial. The most important thing to understand right now is that together these symbols declare our function to the compiler and tell it that it exists. So, what is a function? In computer science, the term function is used a bit more loosely than in mathematics, since functions often express imperative ideas, as in case of C, that is, how to process instead of declarations. For now, suffice it to say, functions define a set of computer statements that work together to carry out a specific task. In C, the statements associated with a function are placed between a curly braces, which mark the beginning and the end of the statements. Together, the curly braces and the statements are called a block. So, this is actually called a block. Let's look at the first line in our functions block. We have this. This line of code is the heart of our program, the one that outputs our greeting to the user console, also known as the terminal in the context of Unix-like operating systems. The text-based interface installed on your computer. This statement is a function call and has two main parts: the name of the library function used to print out greeting, the print function, followed by the data that we will pass to the function seen here between the pair of parentheses. The data we are passing to the function is the string hello world in code and code. The slash, this one is called the slash n. These two together part at the end of the string is a special kind of character called an escape sequence. The slash n escape sequence generates the new line at the end of our text. Strings and escape sequence will be covered in more detail in the later tutorial. We terminate the function call statement with a semicolon. Semicolon, very important. So the compiler knows that it should begin looking for a new statement which it finds on our neckline, which is the return. So this semicolon makes the compiler to understand that we are done with a statement, so it should look for the next one. We have here the return 0 semicolon. Here we say that our main function returns an integer value using the return keyword. The integer value we are returning is 0. But what does this mean exactly? In the specific context of our main function, the value we return is called the exit status, which we report back to the operating system to indicate whether our code ran without error. As our program grows in complexity, we can use order in the integers as codes to indicate various types of errors. This style of providing exit status is a long-standing convention. We will go in much more detail on return value or function later on in this course. So that is a lot to take in even for such a short program. Don't worry if you don't understand all it, and don't worry about memorizing it. You don't learn programming by memorizing, you learn by repetition and by doing. Memorizing all the notes of a given book of piano does not make you concert pianist. You must get on the keyboard and practice and play. Next, we will show you how to take the source code you type in and turn it into an executable file with your compiler. The compiling phase. Compiling is the process we use to describe translating the orders you gave to the compiler in your source code into the machine language that can be run by your operating system and your microprocessor. In this way, your C compiler is a middleman. You talk to the compiler in a language it understands. It understands C source code, and the compiler translates the source into machine code to save you a lot of painstaking, tedious, and writing assembly code. If the compiler finds your source code confusing, it will throw an error along with a message to help you fix up your source code and clear up any confusion. You will then need to try to recompile the code and repeat the process until it compiles without error. Note that the code that compiles without error does not mean it is free of bugs. It just means that the compiler understands the instructions provided by your source code. So now let's run our code on our operating system. I am here on my Linux operating system. So to run it, just type gcc, the name of our file, plus the extension. As we said earlier, the extension file for the C file is c-o proc. This proc is the name of the executable file. So again, don't worry about that for now. We are going to learn by doing in the next tutorial. So by doing this, let's now. So as you can see, we have the hello world message there print out onto our command prompt. On your code block, it will be exactly the same. So thank you guys for watching. See you in the next tutorial. Hope you enjoy.